In this video, we will try to understand how Seaborn can be used to make a different kind of a plot. One more feature of the Seaborn is it has a lot of data set which is available inside. So we are going to use one of the data set which is available inside called as a tips, and we are going to plot a different kind of a plot in Seaborn library. So let's start making a different kind of a plot. First, I'm importing Seaborn as SN, and I'm going to load a dataset called as a tips. So now this tips dataset, uh, let's see how it actually look like. So it has basically 7 different columns. The first column is total bill. The second one is a tip. The next one is a gender, the smoker, non-smoker community. Then the day of people visited, the time, and the size. So let's see. Let's read one data and try to understand that. So the second data says the total bill is 21.01. The total tips paid is this. The mail customer was basically on that day he has come. He was non-smoker. The day was Sunday, dinner, and 3. So might be a husband, wife, and child might have visited on that day. So let's read this data. This is 24.59. Okay, 3.61 is a tip paid female, non-smoker community, Sunday, dinner, 4. So my 4 friends might have visited on that day. And similarly, there are so many data are available. So let's try to understand this. What are the column names? So column names are this. Okay, so what we are going to do, we are going to take some of the plots from here, some of the readings from here, and we are going to plot using a different kind of a plot which is available in the Seaborn. So first plot is a district plot. Okay, so distribution plot is basically the total bill. You can see the distribution of a data over 0 to 60, and the highest number of bill is paid is in between this part. Okay, the density of that. Okay, great. Now I'm going to make a distribution plot for the tips. So wherever there is a maximum bill, there will be a maximum tip will going to come for sure. Now let's make a joint plot of total bill and the tips. So this is going to give you a joint plot in terms of the bar chart and the scatter chart. You can see the maximum data which is coming over here is going to present in the bar chart on both sides. Okay, total bill and total tips. This is also a best way to visualize the data. Now you can add one more feature to this same kind of the things, and I'm going to use a kind as a hex. So the same data will be represented in kind of this kind of a data. You can see the maximum density which is present over here. You can use a rug plot to represent the same kind of a data. And now this is basically called as a regression. So the regression line will also be presented. The regression line is the best fit line to the data. So you can predict the future data using the regression line. I can use a KDE. This is basically going to show you the round shape type of a structure of a data density. Okay, so these are these different joint plot you can make. Just adding some small feature, you can change your graph as per your requirement. Now this is a very special feature of the data which is available called as a pair plot. So when you make a pair plot, all the numerical data will be taken on a X and same numerical data taken on a Y, and it is going to present a pair plot. Now the diagonal graph which is available in the pair plot is not useful. Let me slightly take in a small format to show you. See here, total bill versus total bill, tips versus tips, and we have the next one, size versus size. So the diagonal graph are not useful, but this one is useful. Tips versus total bill versus size, the size versus tips. This way this data can be used for future verification. Okay, so this is the best plot you can make. All the data on the X and Y will be taken, but only the diagonal elements are not useful. You can make a rug plot like this. This is called basically the rug plot of the stick-like data which will be presented. Okay, you can make a KDE plot. Okay, this look like a simple chart which is show the continuous variation. You can make both together to see the data more useful way. Okay, great. Now I'm going to make a bar chart of a size and the people with basically hue of a sex. That means gender-wise data will be separated with the size and the total bill. You can see the orange one is female, the blue one is a male, and 1, 2, 3, 4, 5, 6. So this is basically showing the first is a single person which who has basically visited. This are two people who have visited, six people who have visited, and the total bill paid by them. Obviously, more people, more bill will be paid. A simple logic. Okay, let's take a data and make a counter plot and which is a size. So there are only few people who visited alone. Maximum people who visited are basically two. So using this data, what you can understand that you need to make a table which basically take two people, and you can make best use of a space which is available to your restaurant, because there are very few family which are visiting in a 3, 4, 5, 6. So if you make a bigger table, it will be difficult. The more space will be consumed and less people will be accommodated. So the better to make two tables, table for two, that will be a great idea. Then if a bigger family is visiting, you can just join that table. Great. So that data says a lot of things to us. Okay, the box plot you can make with the size and the total bill. So logic is very simple. More people, more bill. Very simple size. Very simple logic. You can make a violin chart which is available with the size and total bill. You can make a violin chart with hue as a sex, that is a gender. So gender-wise data also can be represented. Great. Okay, so maximum female who's represented on a single data, you can see. Okay, the size data, and you can make one more plot called as a Boxon plot. This also says something like the density of the people who's reducing. Okay, Boxon plot. Okay, size and total bill, same plot. You can make a strip plot. So this basically show a dotted data for each of the size and total bill. You can make a swarm plot. See, I'm just changing the name of the plot, and you can see a different plots which are coming up. You can make a cat plot, size data, everything is same. Cat plot look like a same as a strip plot. Okay. Then we have cat plot with kind points. Okay. You can make see the data. The mid data of this will be joined with one line. Now I'm going to make one more cat plot with kind as boxon. So data will be represented in the boxon format. You can write normal cat plot, and if you don't write, you can write here boxon plot. If you don't want to write kind boxon over here. Okay. So the next plot which we are going to use is a data correlation. So I'm going to make a correlated data from a data set. So this is a correlated data. Okay, all numerical data. And the heat map I'm going to make from the correlation data. Okay, this heat map, the darkened part will be the maximum density part, you can see. Okay, the maximum density part is the darkened part. And the different color represent the correlation of a data. You can see all the plot which is showing on our diagonal are almost same. Okay. So this basically shows the correlation of a data. Logically, it is correct. Size versus total bill. So size versus total bill will be the correlation. But when you take a different data set and try to make a correlation, that makes a lot of sense to you. Now I'm going to make a pivot table from a total bill and a tips and the column as basically the sex, that is gender. So let's make the pivot table. This pivot table shows the sex male and female, the tips which has been paid by them. If NN, that means that data is not available. So logically, if male has paid the bill, the female will not going to pay a bill and the tips for sure. So we are going to make a scatter plot or a pair grid. Okay, so this is basically called as a pair grid, and we are going to make a scatter plot from this data, which is we have presented over here. Okay, this is a one more way of basically observing the data, which is called as a pair plot. Okay, now I'm going to make implot in the Seaborn library. So this is basically take all the data, which is the tips and the bill, and the linear regression line can be made. Now the same implot will be made with the hue as a sex, that is gender wise data. You can see the orange and the blue color will be represented with the gender wise data. Very beautifully, this data is going to say a lot of things to us when you start analyzing it. Okay, I'm going to mark X and cap with the data with the logic of sex. Okay, that means the data which is X mark will be the male and the cap mark will be the female. Okay, I'm going to make one more implot with a column called as a sex-wise data. So you have a sex male and sex female over here, and the data will be separated. Okay, you can make a counter plot with the size and the data. Okay, size of 2 counter plot. You can make a bar chart also, it look like a same. You can make a distribution plot of the tips data. Okay, and the final one, we can make a red plot that is look like a scatter plot itself. So you can see a lot of charts which are possible with Seaborn. Everything is represent with this data set. You can change the data set and you can make your own plots and study the Seaborn library in depth. So this is the best possible tutorial which is available on Seaborn and covers a maximum plot which is required for a data visualization. So after data visualization, you need to make a meaning out of the data that basically requires. So when you observe this data, it does not make any sense to you, but when you visualize the data, it might make some sense to you, and you can use it for a different purpose.